In this video, we're going to look at the 30, 60, 90 triangles that we can construct using the unit circle. So again, just like in the previous video, I've traced from my constructed unit circle just the markings I'm interested in so that it's less cluttered while I'm working on it, just like I did when I was doing the 45s earlier. And we will look at just these. The reason that I included both of these on here is because there will be a lot of very similar things that happen, and it makes sense to tackle them all as a group. So we're going to start right here. Well, we'll start by filling in the coordinates that we definitely already know. We already know that this is 1, 0. It's 1 unit that way from the origin. That this is 0, 1. It's 1 unit up from the origin. Back 1 and down 1. So those are the points that we already understood were 1 away. All of these are also 1 away because each and every one of these is a radius of the unit circle, so each of them will be 1 unit. So let's see what we can figure out about this point. And just like in the other video, I am not going to properly construct this perpendicular line through this point. I am just going to eyeball it using my ruler and my best intentions. That's a 90-degree angle. This is a 30-degree angle, because if you remember, this came from constructing this equilateral triangle here, centered with the marks here and here, to make sure it would have the same radius as these. So that means this is a 60-degree angle, because it's part of that equilateral triangle here. And this is a 30-degree angle. So that means we have a 30, 60, 90 triangle right here. And I know that the hypotenuse is 1. So we're in the same situation as before, where what we know about special right triangles is I know that in a 30, 60, 90 right triangle, that this side is 2s. Let's call it x. No, let's call it x. This side is x, and this side is x root 3. And just like before, this side is 1. So I need to set 2x equal to 1 and solve for x. X is equal to 1/2. So that means this is 1/2, and I need to do a little more work to find this side. Because I have 1/2 times root 3. Well, root 3 is like root 3 over 1. Top times top, bottom times bottom. I have root 3 over 2. So that means for this 30, 60, 90 triangle, if the hypotenuse is 1, this is 1/2. And this is root 3 over 2. So that tells me this coordinate here is root 3 over 2 units this way and 0 up. Just like this is 1 unit this way and 0 up. This one is directly up from there, so it has to be root 3 over 2 units this way. And I know it went half a unit up from there because this is 1/2 up. So I have now found the coordinates of that point. This is going to be the same thing but backwards. So I'll go ahead and fill that one in now. Because this would be a 30-degree angle from here. But we don't really do our angles from there. We do our angles from here, and I'm going to leave some space because there are going to be some other ones before there that I'm going to need to do. So to get there, I had to go 90 up, and then this would be 30 over, this would be 60 over. So 90 plus 60 would be 150. So this would be a 150-degree angle. And it would also have that height of 1/2. And this distance would still be √3/2. But now since I'm going that way, when I write the coordinate, I need to include that direction, that it was a negative √3/2. So this point will be negative √3/2, comma, this one still went up rather than down, so it's positive 1/2. So these two are very similar with different x coordinates. Now let's take a look at this one. This angle here is 60 degrees because it comes from the equilateral triangle that we constructed here. This side length is 1 for the hypotenuse. And I already know if I have a 30, 60, 90 triangle where the hypotenuse is 1, that my short side is 1/2 and my long side is x√3 for the legs. So that means that this side has to be √3/2 because it's the x√3. So this one is going to be √3/2. And I need yet another color to make a nice big muddy mess with there. So let's see what colors I have that I haven't used yet. I think I have a green over here. So this distance here is 1/2. So that means this point up here went 1/2 the distance on the x-axis and √3/2 on the y-axis for that 60-degree angle. Now, if I want to look over here at this one, that would be 90 plus 30. 90 plus 30 is 120. And that's going to be this triangle's mirror over the y-axis. The height of √3/2 and a length back here of 1/2, giving me a coordinate where I went back 1/2 and up √3/2. If I look down here, I'm going to get the ones that match these points but reflected over the x-axis. So by a very similar argument to how we did it in the previous video, this is going to also be a length of 1/2. So this point down here is going to be negative root 3 over 2, comma, negative 1/2, because I went both down and back to get to this point. To get to this angle, I had to go to 180 here and add 30. 180 plus 30 is 210. So this is 210 degrees. By a very similar argument right here, I've got the other one that goes with that. And it would go all the way around to here and down to here, and this angle would be 210 plus 30 would be 240. And it would have coordinates of negative 1/2, because I went back on the x-axis, comma, negative root 3 over 2, because I went back on the y-axis. Last but certainly not least, I've got 2 more over here. This one is going to match with this one. I should have done that with a ruler. I'm getting lazy as I get to my last quadrant. So that's going to be another root 3 over 2. So this one will be positive 1/2, because I went in x direction was positive. Negative root 3 over 2, because I had to go down rather than up. And that is at oops, this one should have gone here to be the 210, the 240, sorry. Okay. This one would be 270 plus 30, so that would be 300 degrees. And last but certainly not least, if we go all the way around to this guy, that would be 330 degrees. And we can find its coordinates by extending this one's arguments down here. And I would get that this is 1/2. This is 3 pi over 2. Or sorry, root 3 over 2. It has been a long day. I apologize. So root 3 over 2 in terms of x distance, and down 1/2 in terms of y distance. And I realize I didn't close that parentheses. So now I have all of my 30, 60, 90 triangles. Here are my 45, 45s. Just realized on this one that needs to be a -1 down there. And if I overlay these, you can see here are all of my critical points that we'll have on a typical unit circle. So you will want to have probably a cleaner copy where you didn't derive all of this in your notes. Printed ones are available in our lessons if you're one of my students and watching this, and if not, then there are many unit circles available on the wider internet that are not in my handwriting and with many overlapping colors. But I think it's useful to see where this comes from. Thank you for watching.